So let us see the synchronous motor in general. A synchronous motor is electrically identical with an alternator or AC generator. AC generator also referred as the synchronous generator. This is synchronous motor. That's why both are very much identical to each other. A given alternator, that is synchronous machine, can be used as a motor when driven electrically. So some characteristics features of a synchronous motor are as follow. So the synchronous machine depends on the input power. We will decide whether to act as a motor or as a generator. So some characteristics features of a synchronous motors are as follow. The first one, it runs either at a synchronous speed or not at all. So while running it maintains a constant speed. The only way to change its speed is to vary the supply frequency. So here N is equal to Ns, and Ns is a RMF, revolving magnetic field, which is given by Ns is equal to 120 F divided by P. Second, it is not inherently self-starting. It has to be run up to a synchronous speed by some means before it can be synchronized to the supply. By some means with the help of the starter devices, either the damper winding or any other starting method. It is capable of being operated under a wide range of power factor, both lagging as well as the leading. Hence, it can be used for power correction purpose, like a synchronous condenser, in addition to the supplying the torque to the drive loads. So what is the principle of operation? So diagram is showing the principle of the rotor and stator is fed from three-phase supply. Stator carries the armature winding, the rotor carries the field winding. We have discussed in detail the basic principle of operation of the synchronous motor in machine 2 in your third year. So let us see again, when a three-phase winding is fed by a three-phase supply, then a magnetic flux of a constant magnitude but rotating at a synchronous speed is produced. That is, Ns is equal to 120 F divided by P. Consider a two-pole stator as shown in the figure, Ns and Ss, in which are shown two stator poles, as I told you earlier, Ns and Ss, rotating at a synchronous speed, say, in the clockwise direction. Since the two similar poles, N of the rotor and Ns of the stator, as well as S and Ss, will repel each other, the rotor tends to rotate in the anti-clockwise direction. But half a period later, stator poles having rotated around interchanges their position. That is, Ns is at the position B and Ss at a point A. Under these conditions, Ns attracts S and S attracts N, and rotor tends to rotate clockwise opposite to previous action. Hence we find that due to the continuous and rapid rotation of the stator poles, the rotor is subjected to torque which tends to move it first in one direction and then in opposite direction like a pendulum. Owing to its large inertia, the rotor cannot instantaneously respond to such a quickly reversing torque, with the result that it remains stationary. That is the reason why synchronous motor is not at all a self-starting.